proven track record of success leading complex projects while managing cross-functional resources to drive efficiency in enterprise technology operations. He's recognized by his peers for skillful leadership and execution of projects related to cloud architecture, cloud migrations, DevSecOps, automation, microservices, and API-driven development. And we also have a second speaker, Naresh Patel. He's the president of Optimize, and he's a serial entrepreneur and technologist. He focuses on the delivery of agile DevSecOps solutions, leveraging heavily in the public cloud. Optimize enables enterprises and federal agencies to accelerate development and delivery of applications that engage customers and drive revenue. Optimize specializes in all aspects of cloud computing, DevSecOps, applications development and systems integration, systems administration, database administration, data warehousing, and information security. Prior to founding Optimize, Mr. Patel co-founded a Silicon Valley-based successful company called GetHired.com. He founded Optimize to share his passion for agile DevOps development and startup experience with commercial enterprises and federal agencies. Optimize is an Amazon AWS advanced consulting partner. So again, we really appreciate you coming out to speak to us tonight, and we're looking forward to your presentation.
So, good evening, everybody. Again, I'm Akil Butt. I'm the Director of Engineering at Optimize. So today we'll be speaking about API management at scale. For those people that are not sure what an API is, essentially it's the base of the digital business that's taking place today. Every large company that you can think of, LinkedIn, Google, Amazon, any company, they're moving to these API-based architectures for their platforms. The most commonly used API that you can think of is Google Maps. Everybody uses Google Maps. So every time your phone actually, you put in your address and you look for navigation instructions, you're actually communicating with the Google Maps API, which is exposed by Google Maps. And they have given your phone or iPhone or Android the permissions to leverage that API. And basically, when you can think of that, like how many different Uber, Lyft, they actually leverage the Google Maps API as well. So you can imagine how much different traffic is coming to this API endpoint, and at the same time is serving traffic to every single one of them. I mean, I'm not going to say I've never had issues with Google Maps, but I'm going to say that the chances of you having issues with it are very low. So when you have so much API-based architectures and systems coming up, the biggest problem will become managing them, and especially at scale. Like I said, you guys can only imagine how many requests would possibly be coming from Uber and Lyft by itself to the Google Maps API to direct their drivers and everybody to the correct locations. Amazon is actually the biggest example that I always bring up, and this is actually a quote from Amazon, their CEO, Jeff Bezos. So he had this whole shift in Amazon.com. He wanted to change the architecture. He could see some things coming up in the future. As you can see, like Amazon's vision in 1997 to where it is today, they themselves could not imagine where they are, right? There's nothing on Amazon that you can't buy. So from that perspective, they started being a bookstore, and now they're the biggest e-commerce website in the world. So Jeff Bezos, he came out, he could see that scaling with e-commerce growing the way it is. It's still growing. Every company is trying to go the e-commerce way. He came out with a practice that was going to help him scale. So these are his words. All teams will expose their data and functionality through service interfaces, which are essentially APIs. The only communication allowed is via service interface calls over the network. All service interfaces, without exception, must be designed from the ground up to externalizable. No exceptions. Anyone who doesn't do this will be fired. So he actually had invested a lot of money into their platform as it was. It was running fine, but at the same time he could see that he was going to come to a halt pretty soon, or he will not be able to scale the way he wanted to. So he came up with a solution, he invested that money, And now, when was the last time you tried to order something on Amazon and it didn't go through? It doesn't happen. They are selling to millions of people on the same second, and those transactions go through. So our topic today is API management at scale. So essentially, why do I want to do API management? Like, what are the benefits to that? So control, visibility, seamless integration with external systems, analytics, how are your APIs doing, monetization. You can literally charge people for calling your API just by your management platform. You can set it up with your monetization or whatever banking system on the back end, and it will automatically do those transactions for you. Also bringing standardization, so like with API management, you can essentially bring the same standard security protocols or governance protocols by leveraging the same platform. And dashboarding. So once we start allowing all this traffic to come in and communicate with our APIs, consume our APIs, and get value out of it, we also want to measure how much our API is being consumed, which ones are busy APIs, and which ones we need to ensure that are never coming down, or we make sure that we make changes to them in a way that never show up to the customer. So while the whole API-driven development aspect is going on, there's also a shift in software development. Monolith applications are becoming a thing of the past. So the new microservices architecture is basically the new way of developing their services. And every service, every microservice essentially is representing an API. So in a microservices architecture, every service has their own CI/CD pipelines, which essentially go through all the security scans and all the different vetting and processes that you have as part of your development lifecycle. There are also various monitoring and security tools that you can leverage, like literally throw into your pipeline and not even have to think about it, and it will just generate a report and throw it to you and say your code is good or not. For microservices, yes?
I'm gonna ask a really naive question here. Can you explain really briefly what the difference is between a microservice and an application?
So an application would essentially, I guess, contain multiple different processes to see basically a function go through. So like we can have an application to essentially go to make a payment and basically purchase something or something like that. A microservice will essentially break it down. So like if you even look at the diagram that I have, the cart is a microservice. The only service the only function that service is giving me is to temporarily put something there, right? And an application would be the whole stack right there. So having the ability to look up toys, fruits, put it into the cart, check out, and acknowledge. That would be one application. The microservices architecture is essentially giving me the opportunity to break that apart. And at the same time, by doing that, I can leverage the same cart for another process as well. So if I'm buying, let's say, towels, and I'm not buying toys, but I want to use the cart service, the microservice does a very specific function. And that's all it does. It will communicate with another service and come back with a response. It will not do more than that. It has to be literally like one specific function that it does. And that could be literally going to another endpoint, getting some data, and bringing it into your database. And then in the future, if somebody queries the microservice, they can get that data from there, because we don't necessarily want to give them access to the endpoint where the microservice got it from. Does that make sense?
So use that for what, for security, and so that you can develop features one by one rapidly?
Yeah. So basically decoupling, right? We want less and less dependencies. So if I want to make a change to the cart service, I don't necessarily have to make a change to the fruit service, right? I just need to, if there's an issue with the cart service, I will clearly know where that issue is just by doing that, by creating a microservice. If it's a specific functionality that's not working, I can easily find that, compared to in a monolith where I have these Java error codes coming up and I'm trying to figure out which process is throwing that error.
So if it breaks, you only have to fix that one tiny little microservice?
Correct.
And not worry about the dependencies?
Nope.
And the same thing with security or permissions or something like that, you'd be able to use it?
That's correct.
Got it.
That's correct.
So in other words, right, the microservice itself is an application, so it's a very small
Yeah.
application that does a very specific task instead of taking the whole thing from putting your item into your cart to checking out, right? In one of the application, you have everything embedded within one application, versus here all the functionality, they are basically fine-grained, handled by small applications called microservices.
And at the same time, while microservices are running, right, so from a virus scan and security perspective, like the hosts that these containers are running on are essentially still secure. They're reporting back continuously in a dashboard fashion, where essentially they're telling you how's the health, are there any issues with security, is there any vulnerable packages within your containers, do you want us to block them, what do you want to do? So essentially we control security in a very, very fine-grained way. We can allow things and we cannot allow things in certain situations. So if any more questions on microservices? All right. So bringing in Apigee. Apigee is actually the API management platform that we will speak about today, but at the same time, there are also similarities with other API management platforms that are out there. Essentially what I'm trying to say is that the core values or the core processes of the different API management platforms in the market right now are the same as far as exposing like the patterns. And but Apigee also has a very, like Google is known for their AI analytics and all those components. So they have built in a very, very rich I guess platform within this API management platform. So as you can see the diagram, essentially Apigee gives you security, analytics, operations, runtime, monetization, mediation, and the developer portal. That's the whole Apigee platform suite, and we're going to actually go through that in more detail as we go on. So just like you use CI/CD pipelines for your code, we leverage the same patterns for creating our API proxies as well to expose those services. And platforms like Apigee essentially give you the ability by exposing different APIs that you can communicate with. And essentially at the end of the day, you have plugins like the ones that are shown on the screen, Apigee Bundle, Linter, the Apically for integration testing. So these are tools that are out there for API testing, but Apigee themselves have also given you tools that you can programmatically use in your pipelines to ensure that you're creating API proxies the correct way. And not even that, essentially this will also bring standardization. So most of our clients where we go, we give them the API pipeline to use, and essentially every development team uses the same API pipeline to go forward. Yes, sir.
Does everybody understand the concept of pipelines in the context of development and deployment?
Nope. Okay, so let me quickly go through. The term is CI/CD pipeline, so continuous integration and continuous deployment. A lot of people do not do the continuous deployment piece, but everybody is pretty much in the CI piece, which is continuous integration. So as you're building an application, essentially you keep making code changes to that application. You start with the code base, and then as you're adding more features, you're taking out features, or you're doing this, that, you keep making code changes. Those code changes, you want to ensure that they go through a rigorous process of ensuring that the code that you're pulling in or the dependencies that you're pulling in are essentially not vulnerable, or they're safe, or they're essentially not going to cause, they will not breach the security of your application or your functions. So the CI/CD pipeline, essentially what we do is we perfect one component. So let's say I check in the code, and now they have a tool called SonarQube, which essentially tells you your code coverage along with like your unit test, and it tells you how good, how cleanly have you written this code. And if SonarQube cannot understand your code, that means there's a problem. SonarQube essentially has a lot of pre-built templates that can leverage. Well, they actually know the different languages that are being leveraged by people. So JavaScript, Node.js, Go, whatever you're using, they can do syntax checking and give you back a response real quick and say, hey, there's a problem with your code. Once you perfect that code, you take that functionality and make that one component of your CI pipeline. Now, every time you make a code change, it's going to go through that process to ensure that your code quality is correct. The next piece becomes integration testing. So once you made that change, for that service to now integrate with another service that it could do previously, can it still do that? To ensure that you're not breaking anything in the process of trying to push out a feature to your application. So essentially it's kind of collaborating or bringing those proven tasks into a streamlined process. So I want my code to get scanned, I want to do an integration test, I ideally want to deploy it to a lower environment where I can do additional performance and other testing. Once everything looks green, I can promote this code to my staging environment, where it will be going before production. Yes, sir.
So the analogy that I like to use with it is that it's like an assembly line.
Yeah,
If it was
yeah,
a factory,
pretty
it's like
much.
an assembly line. And there's a conveyor belt, which is sort of an automation system that at various points along the assembly line can trigger things based on what's happening to your code. So you can trigger a static analysis scan,
Yep.
or you can do functional testing,
Yep.
or you can send messaging to people, or you can antivirus scan,
Yeah.
or at some point you can push it into a test environment,
Yep.
and then putting it into the test environment will trigger certain tests.
Correct.
And then if it fails, it goes back to the beginning, and you start over, people get messages. But it's like an assembly line, and when it gets
Pretty
to
much.
the end of this pipeline, which is really just a fancy cron. You know?
Yeah, exactly.
It's a fancy, it's based on events, so things happen, and at certain times, you can set certain applications to trigger and run, whether it's a
Yep.
scan or whatever.
Yes, sir.
So, it's magnificent for us because it stops the manual work,
Correct.
and it makes things automated, so we make sure that the steps take place every time during
Yep.
the process.
Yes, sir.
So, a question related to that, when they do the code checking, do they check whether there's a hard-coded IP address?
Yes.
Or they should use the fully qualified domain name, if they ever need to use
So,
that?
in certain it really depends what you're checking for. You can basically make that a check. If they see any static IPs in your code, it can give you a report and say you have a static IP in your code. There's customizability to these tools because it's not like one size fits all, right? Your application can act differently compared to a different application. So, because I know in environments where we are using some static IPs, but it depends on what the use case is, right? If I'm doing a simple test right now, and I want to allow that for the simple test to happen, how can I do that, right?
But I think the best practice is you should never use a
Yeah, of course.
hard-coded IP address
Yeah.
in the app.
Yeah,
Otherwise, you will run into a lot of problems.
of course, of course. But at the same time, if you're not that big of an organization and that's all you guys do, what are you going to do? You can't stop development processes, right? From that perspective, if your AWS environment is based on IPs, then that's what you're going to use unless you bring in a DNS server and you create your own entries which will allow you to do the FQDN way. But again, it depends on the use case. And you're right, like from a best practices perspective, it would be a horror show if you are using static values which are changing. So then you're going to have to always update those values, and that will be your CI part. Like you would not make any other code changes. You will just be updating static IPs.
Job security.
Yeah. Or that. Or that. Yes, sir.
I think we're having a great discussion. So on the topic of CI/CD,
Yep.
I know the term CD gets thrown around a lot, whether it's continuous delivery versus continuous deployment.
Yeah, yeah.
Just kind of want to get your take on maybe concisely what that difference is. That way, again, a lot of people
Yeah.
are throwing the term around.
Yeah.
They might know what they're saying, but
Yeah.
sometimes it gets gray. So
So continuous delivery is essentially having an artifact ready to be deployed, ready to be delivered to your application. Continuous deployment is essentially if all of my checks worked out, automatically deployed to production. So a lot of people don't feel comfortable with that. They're like, wait, I would rather have a trigger. So when you add that trigger, you're essentially on continuous delivery. And at that point, if you want to deliver it to production, it's just a click to promote that. So yeah, that's the difference. Essentially, in one of them, you're automatically triggering, and one of them, you're not. Yep. So, so one thing, so we got our API proxies now in Apigee. If we create our APIs and the next phase becomes exposing those APIs. Like how will I got Apigee, I created a bunch of API proxies, which are essentially proxies, like the word says, to your services, to your microservices. How do I expose those? That's essentially where API products come into play. So, for example, if you're giving, the best way to put it would be, so if you have a specific use case that will require an application to have access to 4 different services to complete a process. So that could be checking inventory, if it's there, adding it to a cart. If it's there, once it's there, after that, ask the person to check out. If they check out, take them to payment. They go to payment, they enter their information. Once they make their payment, come back and send an acknowledgement email to them. So in that situation, I need to give them access to 5 different APIs. As I said, microservices are they're single function based. So in that perspective, what I will do is I will create an API product, which essentially will be those 5 API proxies, but now I can secure them with 1 API key, or client credentials when it comes to OAuth. So
You can go back to the first slide, which is the toy store, right?
Yep,
So that the whole thing can be a one product.
correct,
Right,
exactly. So this can be a product that Amazon is exposing. They can say, we have a toy product API product, and if you do that, you can essentially sell your toys on Amazon. Right? So I can add my inventory to yours, so you can basically call my API and confirm that I have the toy that the customer is looking for. So I can basically package all of them into one product and secure that with 1 API key. So every time whoever it is going to be consuming my API, I will have that information, and I can secure that, again, with 1 credential. So it doesn't also, so like I said, like the APIs are actually meant to be used by multiple different services instead of one application to one application kind of relationship. So from that perspective, if I wanted to package the carts API in another product, I can do that. So I can essentially take all of my API proxies and mix match and create different products based on the use cases that my consumers are looking for. The new trend when it comes to security or authentication or authorization for your APIs, OAuth is the model that industry is following. So OAuth is essentially open authorization. It's an open standard for token-based authentication and authorization on the internet. Essentially what it does is it allows you to authenticate somebody without really exposing their username or passwords or anything like that. Have you ever seen this screen before where it says sign in with your Google or sign in with your Facebook account? That's essentially what they're doing. What they're saying is, whichever application is being exposed or that you're signing into, what they're saying is, okay, you know what, we trust credentials that come from Google. So we think that whoever creates a Google account actually gives real information, even though that's an assumption, but still, if you created an email account, you would most likely give them the real information instead of trying to put, John Doe or something and you're really somebody else. So from that perspective, the application makes the choice that we're going to trust Amazon, Google, and Facebook. If anybody has those accounts with those IDPs, which are known as identity providers, we can leverage that identity and give them access or create an account within our application. Is that confusing or does that make sense? Yes, sir.
One question, how do they know that that identity from, let's say, Facebook is real?
So basically the application, what it does is Facebook has, since they're an identity provider, they have a way for you to go to their facebook.com/ I don't know what it is, for you to essentially add your application as one of the applications that can authenticate through Facebook. Facebook gives you that. Then Facebook actually gives you a randomly assigned application ID that you put into your application. So whenever somebody comes to your application, it looks at that application ID and it says, okay, Facebook knows which application this is, and that's who they're authenticating for. So essentially, now think about it. Now you, as an application developer, you don't need to worry about managing users, creating a database to manage those users, manage retention policies and all of that around passwords and all of that. That can turn into a really big mess. Essentially, we're saying we trust Google, Facebook, and Amazon. We're going to leave that to them. Any questions on that? Before OAuth, you weren't really able to federate on that level. The only federation you could really do was with your own AD, like from an enterprise perspective. You could do SSO or some sort of integration with your application, with your AD. But now, what we're seeing is like giants like Google, Facebook, and Amazon, they can also be identity providers for the world. Any questions on that? Yes, sir.
Does this support like a multiple factor authentication?
Yes, it does.
Okay.
Yes, it does. So the first question becomes, okay, I got my API proxy in Apigee, and I know I'm going to be exposing them by creating products, which is essentially a group of APIs. So a developer that wants to consume my API will come to my dev portal, which is the first place in Apigee where a person comes. The dev portal is where me as a developer, I am going to go and expose my API, and an external developer is going to come and consume my API. So I'm creating like a marketplace. And when somebody comes to that, they see all these options. They see that I am essentially exposing these APIs. And if you're interested in them, please feel free to register. So if you look at the details that I have, so the app developer registers themselves in your portal. If access is approved, developer creates a logical app in dev portal that represents his or her app. Developer requests access to our available products. In this situation, I was basically talking about Uber and Lyft. So they're actually requesting access from Google to their navigation product. So their navigation product includes the Maps, Earth, and Location API. So in that situation, Google will get that request. It's a manual process to get approved from Google for that. If they approve your request, you automatically get assigned a consumer key and secret, which is basically going to be your credentials to do that OAuth authentication. So we are using OAuth for external use cases, and you can see why we're using OAuth is because the options for us to do management of IDs and identities is massive. Like imagine being able to leverage the databases, the user base of Amazon, Google, and Facebook. I don't think you need any other IDP in the world to basically host your application. So in this situation, they went to my portal, they requested access to my product, and essentially I approved their product. So now what they do is they come in, they provide their consumer key and secret in base64 format. They call my OAuth API. This URL will be provided to them as part of the dev portal process. They will come with their client credentials. In response, my OAuth API will essentially validate that these are valid credentials. If they are valid credentials, it's going to give them an access token that you can go ahead and basically call my API now. From an OAuth perspective, the application does not care as long as it has an access token. You cannot directly call it using client credentials unless you use something called an API key, which is essentially like a string that you assign to it, and OAuth is the API is able to validate that. So any questions on the process of me requesting access and then consuming the APIs in Apigee? Yes, sir.
Is there a risk of credential harvesting by a man in the middle or some type of malicious development?
It's like any case, yeah. I mean, it's really we're really counting on the people holding on to securing those credentials. But at the same time, our goal is to be prepared for that on the other side, right? So that's a great concern to have, and you will see that we are actually addressing that. Up front. Like we're going to be addressing that going forward. But yes, that is a concern. And at the same time, we have certain throttling and limitations that can detect if something is being abused. If a credential is being abused, it right away cuts it off. We call it spike arrest. So if it like spikes from 20 requests in 1 hour to 2 million requests the next hour, something is up. So it's going to automatically cut it off before you even hit the 2 million mark, though. As part of the platform, Apigee also monitors and analyzes your traffic. So you can see your patterns of how much consumption you have. So like from 9 a.m. to 5 p.m., our consumption is probably high. And we can basically see that on a trend for a weekly basis. And then we can actually set some limitations or throttling because we know where we're kind of capping out. Give it some cushion of 10% and essentially make it there. Once, I guess if we get more popular and our traffic goes up, we can tweak that. But at the same time, we want to understand how much our API is being consumed so we can set up those throttling and be able to detect a man-in-the-middle attack quickly and basically, mitigate it right away. And you're gonna find interesting, some additional slides coming forward. You'll find that interesting. Yes, sir.
Yeah, the question regarding, I assume the transactions between the end-to-end are encrypted?
SSL, yes, SSL, TLS, HTTPS.
Okay, is it SSL or TLS?
Combination of both. I mean, depends on what your situation
So
is.
SSL has been replaced by TLS.
Yeah. Well, I mean, there are legacy systems where you still need to do two SSL and all of those, but we're not really, we're not really going for those. We're focused on OAuth and basically protecting our APIs with TLS.
Well, if the encryption is not secure,
Uh-huh.
the OR may have an illusion thinking this is secure.
No, I mean, our endpoints are secure using TLS, like you're saying, but yeah.
Okay, and then the TLS, which version is that supporting?
Nourish
1.3.
1.3.
1.3?
Yeah.
Okay, that's amazing. Yeah, that's the only version that has not been hacked
Yeah.
so far.
Yeah.
Otherwise, a lot of people not using
Yeah.
1.3 and they have the illusion thinking they have encryption.
Yeah.
It's a HTTPS tunnel, but in reality, that
It's
hackers
not.
are easily get in and out.
Yeah. So once we got our API exposed, right? We got our APIs exposed. We have some mission critical APIs that are will require additional vetting. So LinkedIn, Google, Twitter, they have great API programs as far as their vetting process when it comes to giving access to their APIs. So as far as the vetting process, we basically bring them in. They get access to some of our open APIs that we essentially have open to the public already, but we secure them using Apigee just to see how they integrate with our APIs. For production use case, however, so that's like a sandbox environment. We give them access to a sandbox environment, which is kind of a simulation of what our real environment looks like, but it's really just to integrate, send some payloads, and see if the integration is correct. But for production use cases, we actually, in some cases, have requested demos of their application. So before they consume our API, which is, pretty much a secure API that we don't really want to just give out access to everybody. From a vetting perspective, we let them in by bringing them into the sandbox environment. When they're in the sandbox environment, essentially what we start doing is we start monitoring their integration. We start seeing if they send us any malformed requests, how good of a tenant they are. Like, what are they following our because the developer portal, I should have said this before too, and I apologize for that. The developer portal will also have documentation around your API. Exactly how to communicate, what are the values, what are your options to communicate with our API. And if your consumer is not following that, sending malform requests, then we can basically cut them off right there and say, okay, you know what, you're not following our policy and our documentation, so your client credentials are actually not valid anymore. So you cannot call our API. But at the same time, we have self-serve APIs, which are essentially like open APIs, not really